Bismillahirrahmanirrahim. Now let we analyze TRUSS structure using simplified join method, or what students call easy method. This example from final exam, past final exam paper June 2018, question number 2. Now let we consider this structure. They have a TRUSS structure. They have pin support at A and roller support at D. Okay. First, of course, we need to calculate the reaction at A and D. Okay, at A they have pin support, so they have a reaction in Y and reaction in X. They have two reaction because pin support. At D they have a roller support, so they have one reaction. Okay. Let we consider AY first. Okay, to consider AY, let we consider moment at D. Moment at D, it means 100 multiplied by 3 divided by 4. 100 multiplied by 3 divided by 4 equal to 75. So you have 75 here. In X direction, because they have no external load in X, so X equal to 0. Then we can determine dy. Okay, we can determine dy. 100 kilonewton downward, 75 downward, so at D they have a 175. Okay, now settle our reaction at A and D. Next we will analyze we will analyze the force at A, B, C, E and D. Before we analyze, better we decide how many unknown they have at every joint. At A they have 3 members here. Of course they have unknown in Y here because this is vertical member, unknown in X here because horizontal member, and for AC this is inclined member, so they have an unknown X and Y. At B they have 2 members here in Y direction, vertical and horizontal, so they have an unknown in Y and unknown in X. At D they have 3 members here in X because horizontal member, in Y because vertical member. DE, this is inclined, so they have unknown in X and in Y. At C they have 1, 2, 3, 4 members, X for CB. CA because inclined, they have X and Y unknown. CD because this is vertical member, they have unknown in Y direction. For CE, because this is inclined member, they have X and Y unknown. At E they have 2 members here, both inclined member, so both member they have unknown X, Y, and here also they have X, Y because both inclined. Clearly shows here at A they have 2 unknown in X, 2 unknown in Y, 2 unknown in X, 2 unknown in Y, 2 unknown in X, 2 unknown in Y for E. At C they have 3 unknown in X, 3 unknown in Y. At B they have 1 unknown in X, 1 unknown in Y. Okay, to start your simplified joint method, you will start at joint where at least they have 1 unknown. So for our joint here, at B they have 1 unknown, whether in X or Y. So you can start at B first. Okay, now you analyze joint B. Joint B, they have 1 unknown in X, 1 unknown in Y. In X, balanced by force in X, so they have no force in X, so X equal to 0. And in Y also they have no force in Y direction, so Y equal to 0. So for this member BC, 0, and BA also equal to 0. Okay, it means this X equal to 0 for this member. This Y equal to 0 because for this member. Now at A, instead of 2 unknown in X, 2 unknown in Y, now because member A, B already determined equal to 0, now at A you have 2 unknown in X and 1 unknown in Y. So you can determine Y first because Y, we only have one unknown in Y direction, so better we determine Y first. At joint A, you have a force 75 downward, so balanced by this Y 75 upward. 75 upward balanced by this. Okay, for member AC, when you have determined component Y, so easily you can determine component X. How to determine component X? By using, because this member CA and you want to determine the force in X, so you use the ratio distance X over Y. It means 4 over 3 multiplied by 75. 4 over 3 multiplied by 75, you got a 100 here. 100. It means you have determined Y and X. So one unknown left at joint A, which is in X direction. Okay, in X direction. So 100 kilonewton to the right. So balanced by 100 kilonewton to the left. Now settle joint A. You have determined all the unknown here. Okay, for AD, 100 kilonewton here, so here also 100 kilonewton. This is to the left, this is to the right. It means summation of force in X equal to 0. Okay, similar to joint AC, you have determined this value 75 and 100. You transfer here for X and Y. So 75 upward, 75 downward. To the right 100, to the left 100. Okay, it means you have determined the unknown X and Y here. Okay, settle at B, settle at A. Now we move to D. At D, you have 2 unknown in Y and 1 unknown in X, because X here you have determined already 100. So because you have 1 unknown in X, so you will determine this X first. Okay, you will determine this X. So when you look at this joint D, you have 1 force in X, 100 kilonewton to the right, so balanced by 100 kilonewton to the left, equal to 100, balanced by this force. Okay, it means summation of force in X equal to 0. So for this inclined member, when you have determined this component X, so component Y, easily you can determine by using ratio dimension Y 7 meters divided by 3 meters multiplied by 100. 7 over 3 multiplied by 100, so you got 233.33. Okay, now already determine this Y and X unknown. They have 1 unknown left in Y direction. Okay, so now you focus on the force in Y direction. Upward 175, downward 233.3. So to balance this force, you must have here is a upward 233 minus 175. 233.33 minus 175. You have 58. 58.3. Now settle join D. So this 58.3 you transfer here. This is upward, so here is downward. 58.33. This 233 you transfer here. 100 to the left, 100 to the right. Downward, upward. Okay. Next, after you have determined D, now we move to join E. Join E, we have one unknown left in X and Y. One unknown in X, one unknown in Y. So for X, balanced by this 100, this is to the right, so you must balance by 100 to the left. For Y, you have 100 downward, 233 upward, so you must have balance by downward, 233 minus 100, so this is 133.33. Okay, settle join E. Next, you transfer this component, force component, to here. So this is 100 to the left, 100 to the right. 133 downward, this is upward. Now settle join E, and join C is a last join. So last join, make it join C as a checker. You must check at join C whether they meet the condition summation of force in X, summation of force in Y must equal to 0. In X, 100 to the right, 100 to the left, so meet the condition equal to 0. In Y, upward 133.3, downward 58.3, downward 75. 75 plus 58.3 equal to 133.3, so meet the condition. This is how we calculate the internal forces using simplified joint method. Thank you. Assalamualaikum.